Kavanagh interviews the brightest minds in the world of information management. Want to be on a show? Send an email to info@dmradio.biz. Now, here's your host, Eric Kavanagh.
Ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanagh here, burning right through another year. We're in year 16 of DM Radio, doing this for a long time, and things change and things stay the same. But today we're going to talk about one of the harder nuts to crack. We're going to talk about geospatial data, how it can be used, when it can be used, why it can be used, what it can do, and what the architecture is like, and maybe why it's such a hard nut to crack. So we're going to be hearing from Nima Negahban. He is the CEO of a company called Kinetica, and our good buddy Eugene Burke is with us as well, a consultant, practitioner, budding analyst in the space. We'll talk about what you could do with this stuff and, again, why it matters. So first, I'll just say a couple quick words. There are lots of different database types out there. Most people know relational databases. Most people know tables, Excel spreadsheets, and things of that nature. You also have like an access database, right, which has its own sort of three-dimensional hierarchy. And you have graph databases that have really taken off in the last few years, largely because of folks like Facebook and LinkedIn and Instagram and all these guys who are trying to understand relationships between people. Who do you know that this other person also knows? If you go to LinkedIn and you go to connect with someone, it'll show you who you're connected with that they're connected with. So that's an interesting piece of information to go, okay, well, maybe I should connect with this person. They may know something I need to know. That's another kind of database. There are document databases. There are key value stores, for example, which really like two-column databases. So there are lots of different kinds of database because there are lots of different needs for that. I actually remember interviewing Dr. Michael Stonebreaker in the year 2005. He was on this big push called One Size Does Not Fit All. And his point was that column-oriented databases are very good for analytics because everything in the column is supposed to be the same. And that's good for compression purposes. So there are lots of reasons why you would have different database architectures and styles, and one of them to our show today is geospatial. And with that, Nima Negahban of Kinetica, tell us a bit about Kinetica, why you chose to focus on geospatial, and what you're doing that really makes geospatial analysis easy.
Yeah, thanks for having me. Yeah, I think it's best explained kind of talking about our origin story. So we came out of the DoD, and the goal of this research program that we were on was to consume, over 200 different real-time feeds, a lot of them geospatial, right? And, at the time, this is like 2010, like NoSQL is all the rage, Hadoop is all the rage. And they wanted to give a common query capability to analysts, developers, so that they could make, location intelligence to give to people out in the field. And basically, the problems we saw were like, very poor query latency times because location is compute intensive quite often, right? Data latency problems because, in this case, and this is, for location, pretty common. There's a real-time element. You've got a stream of sensor readings, flowing in, right? And then very limited query flexibility, right? Because, the kind of classic indexing approaches only go so far, right?
Right.
And on top of that, let's say you could get a query to run, the DoD was ahead of this because they had more data, but now, everyone's kind of got this problem. When you've got a lot of spatial data to visualize, the kind of client server model where, the server returns back a huge payload for the browser to try to render, it just doesn't work. And you get a spinning wheel and your browser crashes. So, we really thought about, okay, how do we solve this problem? Well, first, we saw that, the GPU and the CPU are just completely different than how databases were designed, 30 years ago, as far as the common algorithms and data structures. So, we really thought about, okay, we're going to make a database that fully reimagines all of the data structures and algorithms to leverage many core devices, right? And we're going to, make it to be optimized to leverage compute so that data can continuously flow in. So you have simplified data structures, and you have the compute horsepower to do these kind of compute intensive queries that location often involves, right? It's a high cardinality. It's not easily indexed. It's not easily rolled up. And this is something where we wanted to give that capability in a data model that was intuitive for the developers. So even though, we're a, time series and spatial engine, it's still, you're interacting with tables, right? You make tables, you insert rows. So, with that vision, we started to build Kinetica, and, it's really about having an engine that's, kind of primed and ready to take advantage of modern horsepower, right? And, being able to take on advanced location queries means, yes, you can do indexing a little bit, and there's been, newer methods like H3 that help a little bit, but when you're looking at really, kind of enterprise location intelligence, it takes the ability to leverage that compute horsepower to do what you need, and then it can also kind of cross analytic modalities, like so. There's like kind of 2D location, but then there's also LiDAR and 3D, and then there's also kind of like you were alluding to, graph, right? So being able to kind of cross those worlds to be able to drive a intelligence use case for someone who might be doing a connected car, or doing fleet visibility for a fleet that's consists of like thousands or hundreds of thousands of vehicles.
Right. Yeah, that's very useful stuff. And these are, as a kind of leading into this, unwieldy use cases, right? When you have lots of vehicles that are all over the place. And this is why IoT is, I think, kind of a challenge, and why there doesn't still seem to be one vendor at the top of the IoT game. Maybe I'm missing something, but there are lots and lots of companies doing IoT. IBM, of course, has stuff. Lots of the big guys have some offering in that space. But it's highly varied in terms of the objects that are out there at the edge that you're trying to track. It's highly varied in terms of the sensors that you use to keep tabs on things. So there are all these different component parts that have to come together. And then you have to be able to see it and look at it in some meaningful way. And that's probably one of the hardest parts. What do you think?
Oh, absolutely. I mean, one of the things that kind of got us going as a product was our visualization engine. So yes, we can do the feature rendering, like putting the points or shapes on a map, but also doing like heat maps, right? So, having the server side rendering do heat maps, or like class break renderings, so you can kind of get a visual understanding of what's going on. And it's kind of a visual analytic, right? So, with spatial, there's, a lot of senses that need to be kind of interacted with the user, right? Like it's visual, it's structured with the data that's getting returned. There's a performance aspect to it as well, where if you're doing analysis and it comes back hours, takes hours, that doesn't really work. You need to have performance there as well. So it's a tricky use case, and I think for a long time, kind of location has been, I don't know, like a second class citizen, where there just hasn't been as much of a prevalence of it, I guess, across kind of commercial enterprise. And that's changing, yes, with IoT, but also with just the amount of like real-time capability that enterprises have now. They've had these sensors for a long time, but now they're actually saying we're going to capture them, and we're going to try to analyze this and understand and get kind of that visibility that is going to give us that extra 10-20% of efficiency.
That's interesting. I'll ask you another question, then I'll throw it over to Eugene to dive in here. But I'm curious to understand in the execution and the runtime, if you will. I'm sure there are lots of ways you can do this. There's certain data you're going to persist. There's certain data you're going to keep in like an intelligent cache somewhere. And then there's functionality you're going to want to apply at different points along that way to say, okay, what's happening? Or can I predict what will happen next if this is the motion of everything? And you mentioned graph already. So graph is part of your architecture. But can you kind of talk about how you pull, just maybe give one quick use case, how you pull the data in, then how you maybe pre-process it, validate it, deliver it to the user. Can you walk us through sort of the step-by-step process of how this can sometimes work?
Yeah, I mean, so, usually there's kind of, I mean, for, a lot of big use cases, there's the referential data, right? That might be like your road network, and that lives on the graph. And then you're going to have your sensor data that's going to be your continuous flow, right? So, step one is, make sure your referential data is prepped and ready to go. And with Kinetica, like with other databases, you can write, data cleansing jobs. But then once the sensor data starts flowing in, then we have things where we can do things like map matching, like snapping breadcrumbs to elements of the road network, or giving location intelligence operators to basically make sure that that sensor data is it's denoised, right? So once you have that real-time element to be able to make sure it's making sense and make sure that you can quickly query it and understand it, the location kind of characteristics we've talked about, it makes it tricky. But again, with our architecture, we focused on, you've got this high compute engine, you've got internally this data model that combines columnar with a kind of very lightweight graph representation to lets you mix and match between these different worlds. We also have a 3D representation for LiDAR that is coming out next year. So I think with location, it kind of always goes back to, do you have the horsepower to muscle through?
Right.
It also goes into, do you have kind of the analytic robustness to go between these different worlds?
Yeah, that's cool stuff. Eugene, I'll pull you in. I'm sure you got some questions you want to ask. Go ahead.
I have tons, but one clarifying question for the reasonably informed business participant. Can you explain why basically the difference between CPU and GPU, and why this seems to be the foundation of how you're able to achieve the kind of the astonishing throughput that you are?
Yeah, so at this point, we actually have really great performance with the CPU as well, but fundamentally the GPU is just in a very layman's perspective, it's just got, instead of 40 cores, it's 400, or now it's in the thousands of cores, right? So when you have that many cores that are all a little, not a little bit, but there's many more of them, but they're not as capable as the CPU core. How do you structure everything to take advantage of that type of device, right? And that's where you kind of need to structure things in just kind of different ways to make sure you can kind of take advantage of the hardware parallelism that device gave. And now the CPU, it's got you've got 100 core CPUs, 92 core CPUs, but obviously the GPU is still, you're talking thousands of cores. So to be able to take advantage of a device like that, you have to make sure you've structured not just your data, but like your actual algorithms in just entirely different ways that don't kind of fit the your college computer science textbook.
Right. So to boil it down, what we learned in data warehousing 2 decades, 3 decades ago, row and column, row and column, row and column, is now a different way of arranging the data to optimize the way the query performs. And you're throwing tons more power at that query and parallelizing the query, correct?
And the kernel itself is different, right? So like our join algorithms, our join kernels, or our group by kernels are just completely different than like, your standard hash join approaches and things like that. So you need to do both. And, with that kind of investment, and it did take a while, you do start to see some pretty great outperformance. Like, so, when queries are simple, like it's a simple select, we do fine. I mean, it's not that like, there's no big wow factor compared to, what you might expect with anything else. But when you have something that's more complicated, maybe a 3-way join or high cardinality group bys, like something like a TPC-DS might deliver as far as computational intensity, that's when we really outperform, right? Because you can't fall back on simple indexes or pre-aggregated results, and you have to really be able to have the algorithms and data structures to take advantage of that modern compute.
I understand that you work with the FAA.
We do.
Can you give us a rundown, just to paint a picture of the business problem that the FAA brought to you and how your approach solved or addresses the problem?
Yeah, we're a part of their next gen EIM platform, and it's out on YouTube, where you can see what we're doing. They're creating a next generation airspace picture, right? That's real time. That's able to feed ML and AI models for prediction, anomaly detection. So everything you'd want and expect from kind of a 21st century air monitoring system is what the goal of this platform is. And that's what we're powering. We're powering where how the analysts see the tracks, the flight tracks on a map, how the models are determining what is a continuous track or a continuous flight versus because like when you have radar, right, there's no flight ID that comes with the radar, right? It's just an X, a Y, and a timestamp, right? So you have to determine that, okay, these 3 radar pings are this one flight, right? Versus this could be 2 different planes, right? So all of that it lives in Kinetica, and they use their query engine as well, our Kinetica query engine, to be able to see what's going on in real time, but also then look at it in context historically, right? So one of the things that's really important with what we deliver, yes, it's real time, but it's not like stream processing where we're just able to do a small segment, right? You can query any or all of the data, and it's really important when someone's looking at potential dangerous behavior to look and say, okay, let me look at this 5 days ago, or let me do a heat map of activity over the past 3 months, right, in this region, right? Queries like that, so you can get context and a deeper understanding of behavior. That's really and it's taken time for the marketplace to kind of understand the importance of these things, and it's still marketplace is still maturing to understand that need. But that's really where you're going to get a lot of value out of Kinetica.
Yeah, and it's because you brought several different modalities together, right? I mean, the thing is, for a very purpose-built use case, you can use, we were talking earlier, a column-oriented database. But when you get these really complex use cases, that's where you want to be solving one problem here and one problem there, and then you bring it together over here, and that's kind of what you built, right?
Exactly, right. So I mean, to be able to have time series, spatial, graph, vector search all together, and be able to do it, inside of the context of OLAP, that's kind of our special sauce and bread and butter, and that's what makes us different.
Yeah, I remember talking to the folks at Rockset, and we've had them on the show a few times. They do, as I call, 3 indexes. As the data comes in, they're spinning off these 3 indices, and then you can, in very, very short periods of time, start analyzing that data. So it's the same kind of idea, just probably a different approach.
They
but
don't
that's
have
the
graph.
beauty of how. What's that?
But they don't have graph. But
They
yeah,
don't have graph. Okay. All right, well, folks, don't touch that dial. We'll be right back to go deeper into this conversation. We're talking to Nima Negahban from Kinetica and Eugene Burke. We'll be right back with our Geospatial show. You're listening.
Welcome back to DM Radio. Here's your host, Eric Kavanagh.
All right, ladies and gentlemen, back here on DM Radio, talking all things geospatial data. We've got Nima Negahban from Kinetica and our buddy Eugene Burke from the consulting world these days. He's got his own company that he's stood up there. He's doing some work with some other interesting folks out there. And in the medical field, he's been focused for a number of years. But we're talking about geospatial, why it's different, why you should care. And you brought up a couple good points, Nima, and then I'll throw it back over to Eugene in a second. But you want an experience for the developers that they can work with. You want an experience for the business people that they can work with. And that's the hard part, right? I mean, there's number crunching that happens in these engines, but then how you deliver that and how they work with it, that's really important stuff, to be able to get stuff done and know what to do and where to go and not be looking at a command prompt all day. So maybe talk quickly about the interface and how you're able to enable those folks to do this stuff, and we'll go from there.
Yeah, I mean, we really try to take a standards-based approach. So, we're a Postgres compliant database, right? So you can use the Postgres ecosystem of tools, libraries, frameworks, right? So, if I'm a developer and I know how to use Postgres, I can get started with Kinetica immediately, right? And then, we come out of the box with some tools like a SQL Notebook tool that has the WMS mapping capability right there. We have a lightweight BI tool that also has that server-side rendering mapping capability. And we're also putting out map plugins for all the major BI platforms. So we have one for Tableau, for Superset. We're going to be putting one out with Power BI. So, we have an engine that's very performant, and we have this rendering capability also that's really powerful. So, one of the things that we are focused on is like, you do your analytic where you do your analytic, right? We're not trying to force you to use all of our tools, right? We just want to make sure, we can deliver our value to the tool that you're comfortable with.
Yeah, that rendering capability is important, right? That's showing you what you're looking at, basically. It's a visualization layer.
You have that
Did you build that?
Right.
You guys built that yourselves?
Yeah, and you have that like back and forth between your map and the other widgets in your dashboard. That's really important, right? Call it like pattern of life analysis, where like you kind of keep digging and keep kind of drilling down. That's something that's crucial for a lot of the use cases that we focus on. It's really powerful to understand like customer behavior, even like customer 360 or fleet behavior. It's something that is important for like data science, where you might be doing data exploration to determine what's the right features to use for your model. All those things kind of go back to having a really interactive visual experience with the data.
Mm-hmm. Yeah, and you want to be able to zoom in and then zoom out, and then zoom in and then zoom out, and do that at the speed of thought or at the speed of fluid human exploration.
Right.
And if your rendering takes too long, you lose that. If your computation takes too long, you lose that. So you need all of these bits and pieces to be as functional as possible in their domains, and then you bring that together to the user for their experience, right?
Right. I mean, like if you think about like the telcos, right? Like they look at cell phone tower pings and understand customer behavior, or they look at where there might be a concentration of activity and they have weak broadband signal strength and they need to place a tower, right? There's all sorts of different things where in that case just showing the points doesn't really do much, but like making a heat map is incredibly powerful, right? So to be able to show the data where the visualization itself is kind of an analytic in its own right as well, is what's becoming kind of what these big enterprises are looking for, because they get it, and they want to make sure that they're understanding their customer or their fleet or whatever they're tracking as best as possible.
Yeah, that's interesting. What other data, before I give it back to Eugene, what other data are you pulling in? Because so for example, in the airline use case, obviously you can see radar and you're trying to figure out, okay, is this that flight? Is it some other flight? Is that flight late?
Right.
What other kinds of data do you pull in, and how do you pull that in?
Right. So, it's dependent on the customer, but like, a lot of these cases, you'll have, like we talked about, like there's that referential data, like flight schedules, right? And then you have like your high volume sensor streams, or, your real-time data that's flowing in. And then you've got, and the way it flows in is just, again, we're Postgres compliant, right? So, we can consume at a very, very high volume, like millions of records a second, but you're still just using all the standard tools that you'd be accustomed to, and then it's up to the developer to say, okay, I want to deploy this model where I'm comparing these all my breadcrumbs to my flight schedules, and there's a lot that goes into kind of not to get too much in the weeds, but like, flight determination as far as like matching each radar reading to, what flight it actually is. It gets, there's a huge, it's kind of called like, they call it a tracker, right? And so like Kinetica has its own tracker, but, we also work with other trackers, and like the whole tracker domain is kind of a whole world unto itself.
Wow. Eugene, I see your wheels turning over there.
Yeah, I guess in a past life, I had a challenge kind of brought to me by a product management group, where it was a healthcare network delivery company, where we built and leased out healthcare provider networks to the big providers like Humana, Anthem, Blue Cross Blue Shields. And one of our challenges was to build a network that was adequate, that complied with the CMS adequacy regulations, that if you build a network, you have to have providers within X number of miles of your plan participants, and they have to be able to actually access your network. It has to be adequate enough to provide their service. And we looked at a number of different solutions and were going to pay several $100,000 for something that purported to be a solution. We didn't do it because we thought, well, maybe we could build it ourselves.
Mhm.
So this is geospatial, and it is not necessarily real time and not necessarily a high, lot of transactional data. But one of our qualms was, hey, we just paid several $100,000 to build a cloud data warehouse with one of the flavors of the day, and the executive leadership team was a little bit reluctant to shell out another couple $100,000 too. So if someone brought that kind of problem to you to say, I want to know if something I've built on the ground is geospatially meeting requirements, regulatory compliance requirements in real time, is that in your sweet spot of applications to build?
Yeah, I mean, that type of use case definitely is. I mean, I would say also kind of that experience is like very, very common right now. I'd say more common than ever, where enterprises have made their decisions, their significant decisions around kind of what is their authoritative, cloud data warehouse or data warehouse product that is going to lead them for the next, 5 to 10 years. And, they're looking for solutions that work with that, right? So there's very little appetite to, bring in another authoritative source. So that's something that we've really focused on, is making that very easy. So, Snowflake or Databricks, just, having us as a speed layer, that can do that location intelligence or time and space analysis, to make sure that, we're an augmentation or a supplementation to their enterprise data investment, right? And to that particular use case, it kind of goes back to what we've been talking about. You need a graph engine to be able to model the road network, right? Because to have this adequacy, it's about, you're talking about making sure all the patients can be within a certain drive time of all the providers, right? So you have that graph network, and then you've got folks that sit upon that graph, and you kind of do the graph solve, and then you also bring in some spatial analysis and OLAP, and there's that mixing and matching of a compute intensive query that makes that hard. And what a lot of enterprises do try to do to solve this is just like what you guys did. It's like, hey, we'll just build it ourselves, or maybe we'll find like a vendor that has like a kind of a last mile capability for this in particular. And usually it's something where trying to build it yourself is just very painful, and trying to just find a single use application is probably not the best use of capital.
Mm-hmm. Yeah. And you have so if you open up your knife drawer, you see knives of every shape and size. And if you want a bony knife, you don't want a butcher knife, right? And there are certain applications. So speed layer is probably you don't mind that as a description for your.
Oh yeah.
Okay.
Absolutely. I mean, we're an analytic engine that gives you this compute intensive capability, and we've built up a lot of features that make it easy to act as that speed layer, consuming from your authoritative store. That's where we want to sit in the stack.
Yeah, I'd have to imagine you're very useful for things like urban planning, right? Or
smart cities, urban planning, but also like our time series capability. We have some big financial customers where they've got tick data, order data, trade data flowing into Kinetica as well as their authoritative store, and then they're doing things like FRTB or transaction cost analysis, whatever you might want to do, where data latency needs to be low and the queries are complex.
Yeah, that's interesting. I remember learning about a use case. This is probably 5-6 years ago, interviewing someone from Kinetica, in fact, about the garbage cans all around a particular city. And you have sensors in the garbage cans, and they will alert you when they know, hey, we're full now. Right. And it might seem silly, but if you're running the budget for the city of New York, let's just say, or Boston, or any major city, like if I can cut that route time in half and still effectively get all the trash out of there, that's a huge win. I mean, a lot of people don't realize how much money goes into this stuff, and there's a heck of a lot of money that goes in there. So you can learn route optimization. You can save money on not having too many trucks on the streets. Like all these different things are affected by that. But unless you can crunch the numbers before that driver gets in his truck and gets out on the street, or I guess you could update it as it goes along, you're not going to be able to solve that problem, but they can solve it because they have Kinetica at the foundation, right?
Right. Yeah. I mean, logistics is can get really complicated. I mean, like the Southwest kind of missed flight problem, right? Where last Christmas they had to take all of these flights out of circulation because they don't have a hub and spoke model. Like those are the things that like a Kinetica can tackle well, because it's got these solvers, and you can interact with them in a way that is, if you know SQL, you can understand how to leverage them.
Right. Well, and also planning. Like I remember one of the earliest use cases that I learned about, and this is probably 15 years ago now, or maybe 13 years ago, Alteryx, like way back when. One of the cool things that they did was to be able to incorporate third-party data, like population data, maps back in the day. This is, before everyone had Google Maps, for example. But it becomes very important to know, okay, well, how many people of this income bracket are in this neighborhood? How many people are in that neighborhood? What's it going to cost us to build this new store? What kind of predictions can we get on revenue? Well, all that stuff can really be fed by third-party data, transactional data, predictive algorithms, and so on and so forth. And you can really get a good high level of confidence. Okay, if we build a Target store at Lamar and Fifth Avenue, it's going to go somewhere because we've done the numbers on all these people in this region. That's something else that you guys would be good at, right?
Yeah, I mean, we have a number of customers that are data providers themselves, right? Where they're taking raw collections of foot traffic, doing those kind of analytics and AI that you're talking about, and then selling that back out as a data product so that other enterprises can understand their customer better and where they, what their interests might be at a given time and location.
Yeah, well, I mean, just not to get too fancy on this, but I get all excited about the possibilities when you can get this data. I mean, I'll give you a quick example. We've got about a minute and a half in this segment, but I can see all the cars coming into town in New York City, and I can see how many BMWs there are and how many Mercedes, et cetera. And you could capture that information and feed it to big providers like shopping malls and things of this nature. Be like, oh, it's going to be a bumper crop day. As long as once you have a baseline to understand what it means, then as you get new data in, it's like, oh, there's a whole bunch more people coming in. So alert the dealership, bring an extra person into the office today, right? Right.
Yeah. I mean, I think really it comes back down to like who has access to that data and able to kind of marshal it into a solution like Kinetica. I mean, there are lots of companies that are working on that and being pretty successful, especially using application SDKs that are running on your phone. Even though Apple's done a good job, there's still a lot of activity there, and it's building some pretty interesting data products that enterprises use.
Yeah, data products. I mean, we'll be doing shows about that for the next few years, I'm quite sure, because that represents a mindset change and a maturity in the industry, that we're moving beyond just the database architecture into what is the end user really going to want to do with this stuff. That's a data product, and that's really, I think it's the future of our industry, quite frankly, is to focus on data products that people need. We got to go to a break. We'll be right back, folks. You're listening to DM Radio.
Welcome back to DM Radio. Here's your host, Eric Kavanagh.
All right, folks, back here on DM Radio, talking to Nima Negahban from Kinetica and Eugene Burke, who's working with us actually on a couple of stealth projects. We'll have to reveal those sooner or later. But at the break, we started chatting about data products. And Nima, I'll throw it over to you first. I really look at this as a major inflection point in our industry. We understood, of course, data warehouses and various components like network security, and there are all these different things you have to do to run your business. But the fact that we're now focused on building data products, I think it represents a real maturation in the industry, because the data product is something that the business can then use. They don't have to worry about connecting it to things and calling IT to make sure it still works. Like, oh, my printer is broken. Can you fix that for me? Like a data product is a working solution that's providing data for a specific business value. And I think that's really taking off. And I think it's very good news. What do you think?
Yeah, it's one of our kind of highest growing customer segments. But yeah, just like, there's last mile applications, these data product providers, like it's just the same concept. It's taking data to that last mile where they've done all the enrichment, all the cleansing, all of the data science necessary to, deliver what you ultimately want. Right. So there's a ton of startups, that are working towards that vision. And I think it does reflect the maturation of the space where data is seen as itself the final product.
Yeah, and real quick, you had mentioned using Gen AI for some of your new solutions. Can you talk about how you use generative AI and what component parts of that new evolving stack you're using and what they do?
Yeah, so I mean, one thing we've done is we've basically brought an LLM into the engine itself, so you can essentially ask questions directly to the database. You can kind of think of it like we call it like a data co-pilot. You basically tell us which tables you want to have in a context, and we'll also be recording all the different queries you've done, and essentially we'll talk to our LLM under the hood for you, and you just ask questions. That'll generate SQL, and then we'll run that SQL in a performant way. And then that SQL can be pretty complicated, and we've got things that we've done to make sure that it's accurate, even if it's a complex question. And it's a great way to leverage the generative AI LLM ecosystem for real-time data, right, and for spatial data. And I think we've got a number of customers that literally have chatbots now that sit alongside their applications where they're wanting to know, like, do I have anything that is going to be a problem for me over the next 2 hours, right? And they're able to generate the right SQL and calls.
That's pretty funny. I'm old enough to remember a technology, I bet Eugene does too, called Progress Easy Ask. And this was like I want to say like 2007 maybe. And what they did that was interesting is you would type in a natural language query and then it would build the SQL query for you on the screen underneath. So you could see kind of what it was doing and how it was doing it. And it reminds me, I just came back from Boomi World yesterday. I was Tuesday out in Silicon Valley. And one of the guys there, who was one of the top technologists, he made this really, really good point, which is that we're now in this new era where we don't have to know how to talk machine language to the machines. We can talk human language to the machines, and they can understand that and do their machine thing, which I think is fascinating. And and just real quick, I'd like to get your take on this, and then Eugene as well. As I think about the power of these new foundational models, is what they're called. Well, obviously, generating text is very interesting stuff. It's not always accurate. We have to watch out for that. But if they can also talk machine language, which they can write in COBOL and Java and other things of this nature. But if you can get down to the point where you're really able to look at network traffic, for example, or look at traffic of data inside applications to understand where it's going and what it's really doing, that gets very interesting, because then you can start optimizing the granular flow of information from one place to another. And you can start understanding how these two applications work together. And a lot of that stuff has been pretty gray for a long time. You got this whole observability space that's sprung up now, in large part because of Kubernetes, because we need some way to see what it's doing in there. Right. But I'm just curious to know your thoughts on all that. First, Nima, and then Eugene.
Yeah, I mean, I think the kind of hype of like what someone who's not in our arena kind of thinks what generative AI is or is going to be is around this notion of like chain of thought, right, where you've got multiple LLM agents working together and referencing and querying data and databases, right, to basically get input and then take that next iterative step to do much more complicated workflows and interventions, beyond just like kind of like what we do, like what most people do right now, which is like a kind of one-shot text generation, right? So there's really, there's obviously like Auto GPT, and there's also like Research GPT, where they're open source projects and they're kind of showing off the beginnings of creating these chain of thought frameworks. And it's exciting for us as a database because all of these LLMs are going to be writing queries on the fly, and they're going to need a database that can do them quickly because they need that input to take their next step, right? And so it's also about being a performant engine and being able to handle a wide variety of questions, right? So we think that we call it kind of like the generative query future, where the source of query is not going to be users, it's going to be other LLM agents, right? Doing complex workflows.
That's going to get crazy. It's really
powerful. It's very powerful.
Right now it's limited to RAG, like retrieval augmented generation and vector search, and that's why you've seen that vector search space explode over the past year. And that's all great, but as these these workflows get more advanced, it's going to be asking questions of these data silos or databases, and needing that input quickly to take the next decision step.
Yeah, Eugene, you're getting into some really deep water, and we talk about guardrails all the time with Gen AI. You're going to need system guardrails essentially to be able to understand what this thing wants to do now, because it is an automaton, right? And you just let an automaton loose in your network, well, it can do all kind of stuff. Like, I know Eugene said he wanted a meeting with Bob tomorrow. I'll just go ahead and set that up for him. Just doing small,
it overheard my phone say
insignificant,
yes, exactly.
Right? Well, what was the South Park episode where they trolled Amazon or whatever it was, and they said, "Oh, buy 10 red umbrellas or something," and the the Amazon thing spun up and started buying stuff. It's like, whoa, hold on.
Pretty soon your garage door's opening and they're dropping 10 umbrellas in your garage.
And you're like, wait a minute, I didn't order this. Oh, yeah, you did.
Or even like, and in the immediate, like in the short term, there's like even kind of simpler data access control vulnerabilities that enterprises aren't realizing right now, where people can interact with the LLM, and then there isn't the kind of pass-through security system like you have with a database or an application, and that LLM might be inadvertently matching a vector that's going to pull a document that person shouldn't see, right? So there's things like that are kind of, everyone's been in a rush to deliver like these very cool and innovative capabilities, which is great, but then there's a lot of questions, and I think there's definitely going to be solutions and a whole ecosystem of products that come out of this to solve these challenges.
Well, especially in the multi and the hybrid cloud world, where you don't necessarily, if you're the CISO or you're the CIO, and you don't necessarily know if that new workflow you're putting out there, what clouds it's touching, and whether you're violating some kind of requirement or some kind of compliance obligation.
And how do you prompt cleanse, right? A user like if I'm a user and I'm interacting with an LM, just like you can do SQL injection, you can do prompt injections, right? And how do you test for that, right? Like that whole world is wide open right now, right? Because if you remember in the earlier days of Chat GPT, like you could trick it into telling you things that it shouldn't be telling you, right? And it's gotten kind of less fun because like any type of question you ask now, it just kind of gives you this blanket answer. But when you look at the enterprise space, those same types of security exploits are going to be a challenge, and you're going to have to be able to manage and test and make sure that those aren't an opportunity for
there's a new term for CISOs to learn: prompt injection.
Right.
Yeah. No, that's very true. And the challenge again is that we're already moving at light speed. And I got to tell you, I've never seen a space evolve as quickly as this one is. This Gen AI space. It's happening very, very fast. You saw I had Naveen Rao on the show like days after his deal closed with Databricks, and we were marveling at how fast that deal went down. It was a $1.3 billion deal in record time. Like that's a lot of money. And Anthropic just threw $4 billion or something into or Amazon into Anthropic. You're like, how many billions? Like it used to be a lot if it was just shy of 1 billion. Now it's like multiple billions. Well, folks, send me an email, info@dmradio.biz. You have been listening to DM Radio.